Perfect. So let's get into it. What are we doing in this webinar? So we sometimes get comments from our customers, our resellers, about Ubiquiti's ability to scale and how it would work across multiple sites. And some of them have concerns that it might not be as scalable as what they would need for SD-WAN solutions. Hopefully by the end of this, I will put those fears to bed. Ubiquiti does have massive scalability support, not only from managing thousands of sites, but also in terms of connecting potentially up to 1,000 sites remotely to each other for connectivity, VPN connectivity. So most of the times we speak with partners on this, we get comments around the site-to-site VPN capabilities, but specifically focusing on traditional VPN setups. So using normal tools like WireGuard or something similar to establish a VPN, and then the tedious process that goes behind that. So by the end of this should give you a good idea of what's possible in terms of scale for Ubiquiti, and specifically Site Magic. It's basically Site Magic in a nutshell is just a super simplified WireGuard VPN tunnel with OSPF routing to make sure that the connectivity is maintained. So if you don't want to use Site Magic for your deployments, that's also fine and well. Ubiquiti does support traditional VPNs, site-to-site VPNs, client-to-site VPNs, etc. So if you want more granular control, and even advanced routing protocols like OSPF or BGP. So there is definitely options around all that if you don't want to go down the Site Magic path. Just before we jump into Site Magic, I quickly want to highlight something that I get a lot of questions on. So we get tons of calls from people asking us that they have customers that are in very remote parts of Australia, and they are using either 4G connectivity or more than likely a Starlink connection. And the big problem that they're trying to overcome is that because it's a Starlink or a 4G connection, you're limited to CGNAT. So basically meaning that you can't have a static external IP address most of the time. So with Starlink, yes, there is an option around getting a business account from them, but it is a lot more expensive to do that. So the other way to get around that is with stuff like dynamic DNS or tailscale, etc. But those can be cumbersome in their own way. So what we want to do, or what we want to enable, is just the ability for customers to reach into their network environment without getting a static IP address and to overcome CGNAT. The typical use case is someone has a big farm, they want to look at their cameras, they want to remotely trigger their alarm panels to activate or something along those lines, or even like powering up water pumps and stuff. So with that, the problem is always, again, getting around CGNAT. So Ubiquiti does have a function on most of their gateways called teleport. Essentially, it's basically Ubiquiti taking over the dynamic DNS portion. It's a very oversimplified way to put it, but it allows the Ubiquiti gateway to be reachable via the teleport app or the Wi-Fi Man app, and allows you to reach in from anywhere in the world via simple VPN. The nice thing here is it's just one click. You go send an invite to somebody. It takes them through the guide on how to set a how to set this up on their device, and beyond that, you can just connect. So it solves that problem of CGNAT. It gets you into the environment very quickly, and it does tend to just go through everything. Like even if there's firewalls around it or it's double natted and stuff like that, it still just tends to work. So highly recommend checking this out. Again, it's just WireGuard in the back end, so it's an established VPN technology. Ubiquiti just make it easier for us to do it. Okay, and then moving on to what the main topic is for today is Site Magic. So we're going to start off with just I think it's just one slide, and then we'll delve straight into the tech side of it. And we're going to start by taking a look at the mesh side of it. So there is two methodologies within Site Magic and Ubiquiti, which you'll see in the interface. One is mesh, and the other one is hub and spoke. So the main technology driving both of these is still just OSPF and WireGuard. So the underlying tech behind all of it, behind both of them, is OSPF and WireGuard. So one of the big things that we tend to use mesh for is connecting multiple sites, and just having a decentralized mechanism for connecting between different branches. So the same underlying technology that drives OSPF in terms of dynamically selecting paths is implemented along with this, which means it's a very dynamic thing that updates based on your real world environments. So in a mesh topology, essentially every single site, so a site would be, let's say, a customer's business. And let's say, for example, Lido. We have 5 branches, and each one of those would be treated as their own individual site. For those sites, we would have our own gateway. So Sydney office would have a UCG Max, Leader's head office might have a UDM Pro Max, a different bunch of hardware, and all these different branches essentially need to communicate to each other because they have resources that need to be shared between them. A common example would be stuff like printers or Active Directory servers or something along those lines, which are on one property, but not on the others. So we need to connect all these things back to each other in a secure and stable way. That's exactly what this VPN technology is meant to do. With mesh technology, the way it's done is every single site connects back to every other site. So every site builds a VPN tunnel to every other site. So what I mean by this is the Sydney office would build a VPN tunnel to the head office, the Melbourne office, and the Perth office. And all the other branches do the same thing. So the concept behind that is we always have a route to certain like resources, and it basically means that we have one logical network, so or multiple logical networks, but basically direct access to each other. So we're just trunking the traffic across the VPN tunnel. So ideally, this is used for environments where we need fast, super low latency, and secure communication between different branches. A very common example might be Active Directory servers, where someone's trying to like log into their Microsoft account at head office, but it needs to check back to the Active Directory server. Or, for example, a NVR is on, or a NAS is on the Perth office, and you need to push data from your head office down to the NAS for backup purposes. So that's exactly where these things are useful for. So it's ideal for multi-branch office environments, especially if you're sharing large files. If you, for example, have customers that have engineering workloads where they need to collaborate across multiple sites, or we just have local site servers that you need to replicate to each one of these other sites as well. So sites can route traffic between each other, and even if a site goes down, it could potentially still find its path to the other sites that we're trying to get to. Just a quick and important note here as well is that with this, you can see that I have one site that is a public IP address or static public IP address, and then the rest of them are just NAT, CG NAT. So it means I only have to have one site with a static external IP, and all the other sites can connect back to that site or to the other sites and establish this mesh VPN, even if they don't have a public IP address. This is a good way to get around the problem of like having limited connectivity options at specific locations. So you can have, for example, a public IP address at our head office, but one of the other branches is just a small remote branch. They're using Starlink and they have CGNAT, so they don't have an option to do static IPs. So that's a very viable option. In this scenario, Mesh just works to do that. It automatically establishes those WireGuard VPN tunnels and allows connectivity between them. There's no, in the scenario, there is no single central HQ per se. So there's no head office or a hub that is responsible for everything. Each one of these sites is responsible for their own connectivity and establishing their own paths to the other sites. So there is some caveats with this if you only have one public IP address. I'm going to talk about that in a moment. In the real world, you'll probably have more than that. You'll have a couple of public IP addresses and some CGNAT at sites potentially. So the big benefit here is that this is potentially faster. This is the lowest latency to go between different sites where I would want to send files from one to the other. I can establish a direct route to that. I don't have to go through a hub first to relay that traffic to somebody else. So lower latency, it's faster. Um, the problem with hub and spoke topologies is that the hub and spoke, or the hub, always happens through the hub itself, meaning that traffic goes there first and then out to where it needs to be. So in this scenario, we also have redundancy and resiliency between these sites. There's more paths, more failover possibilities, and no single device influences all the other devices, potentially. The downside to this is security. Each site can theoretically reach the other site. So if I have a virus or something that's spreading across one network, potentially it can branch out into my other networks as well. That's one of the drawbacks to this. That being said, Ubiquiti gateways are obviously, it's a gateway, so it has a firewall built into it, meaning that it should still inspect the traffic that's coming to that gateway irrespective. So not too concerned about that. But for security purposes, we tend to not use mesh networks or mesh VPNs. One of the big problems as well is that we cannot have subnets that overlap. A very common thing that we see and everyone does is as a IT technician or installer, if you're deploying 5 branches, you'll typically reuse the same network ranges. You'll go, okay, cool, I'm going to use 192.168.1.1 as one of my ranges, and then I'm going to reuse that same topology for every other branch for the customer. That's all fine and well. It works for the individual sites, but when we're doing a site-to-site VPN, we can't do that because if I then go try and reach 192.168.1.1, then I have 4 different instances of that happening. So which one do I go to? From a logical perspective, we don't want that. We don't want to allow that. And that's the problem with mesh networking or mesh um, VPNs, is that each one of the subnets has to be unique. And it's very often that you'll find overlap. And I'm actually going to show you what it looks like in Ubiquiti, how it doesn't allow us to have that overlap. So that's one of the limitations. The other limitations is that you can only do 20 sites at a max with mesh site-to-site VPNs. The reason for that is if you have 20 different sites, it basically means that one branch has to maintain 20 separate VPN tunnels to each of the other branches, and same thing for everything else. So you just end up scaling massively, even with a small number of sites. So it's one of those things that we want to get around. So when we have a scenario like this, where we only have one public IP address and multiple CGNAT devices, just know that if you lose the one device with your public IP address, it potentially means the VPN will fail because it doesn't know or doesn't have a logical way to route the traffic. That's not to say that the hubs, or sorry, the individual sites will fail. It just means that they can't reach specific resources and potentially can't reach each other, but they can still access the internet, etc. So just something to be aware of. So let's go look at the practical setup here. So I'm currently in the site manager. This is the normal place where everyone goes to set up their Ubiquiti sites. I'm just creating a site group called the Ubiquiti Leader Displays, and you'll see in the site group I have multiple different sites, different branches. One thing that is critical to note on this page is that you have to be the owner of a site as well. So you'll see some of them I'm invited and some of them I am the owner of. If you are invited to a site, it means you're a super admin or normal admin and you can't actually fully set up the mesh or fully set up the site-to-site VPNs. So I'm just hopping over very quickly to the SD-WAN feature here. You'll see hub and spoke is there. We can set this up in a moment. And then we also have mesh. So I'm going to set up mesh first because this is the main one we're going to demonstrate. And hub and spoke basically follows the same rhyme and reason. In mesh, I basically just need to select which sites are going to be part of this VPN. And it's very easy to do, except in this instance, you'll see that I'm not actually able to create this. It doesn't allow me to save it. The reason for that is because I don't have a site that has a public IP address or static public IP address. So in that scenario, I'm not actually able to create this site-to-site VPN. So the same is true for both Site Magic types as well. So if you're going for hub and spoke and a mesh, you need to have at least one static external IP, but ideally more. But at least it does allow remote sites on CGNAT to still connect. Okay, so what I've done is I've changed the site called Leader Header Office to make me the owner of that. Perth I'm keeping as just a super admin account. And what I can now do is the main header office has a public IP address. So I'm just going to create a new mesh here and just give this a name, Leader Internal SD-WAN. You can obviously call this whatever you want. On the site, just selecting the different things, and you'll see right next to it, it says public IP address. That is what we want. All the other ones, if it's offline, it won't allow you to select it. All the other ones, you'll see they are actually double natted, so they're giving 192 addresses, etc., which is not what you'll see in the real world, but just for our labs. And we just go save. What it'll now do is pull up a list of all the subnets on each one of those gateways. And you'll see there is a ton of them that overlap and a ton of them that are unique. I now need to just decide which networks do I want to link to each other. So the internet, like the internet functionality, I obviously won't be able to just select, but any of the other subnets I can potentially have linked, provided that they don't overlap. So I can select, for example, the corporate network in my Melbourne office to link through to the camera network at my demo center. Whatever I wanted to choose, I can just click them all. You'll see as you start clicking that where there is a overlap, so if someone or if one of the other networks uses that subnet as well, it won't allow you to select it. So for example, Sydney and Melbourne, they both use 10.77. It doesn't allow me to select those subnets. So it's a very clever way to make sure you're not stepping on any of the other subnets that you've already done. You also need to make sure that you're selecting all of the sites to pick what needs to be connected. Okay, once that's done, it takes a few seconds for the VPN to establish. It is actually very quick to do this, especially for guys that are very familiar with setting up site-to-site VPNs. This is normally a 2 to 3 day process where you go and check which networks are in use, and then go back and set up the VPNs and making sure that you're not stepping on other subnets. It tends to be a tedious process. And this is pretty much it. So you'll see it's now establishing all the tunnels, and it has done all of its routing already. That's how fast it really is. So what I could now do is I can go onto any one of these sites. I can become a part of that site potentially and just do like a ping test to somebody else or somewhere else, and I should have connectivity. Just a note here that you will not see this VPN show up in any of your VPN server, VPN clients, or site-to-site VPN tabs. You can only see it through the site manager. It is something that we've also raised back to Ubiquiti as well. I think it should be visible there. The one that's in there at the moment is just another one that I've created, but you can't see that tunnels exist. On the routing tables, etc., you can, but on the just interface for it, you can't. And you'll see as well that if I try to select OSPF as one of my dynamic routing protocols, it doesn't allow me to do it because it's already using OSPF on these gateways as part of Site Magic. So all of my branches are now linked. All the networks that I selected are linked, and I can effectively start communicating between them. So a practical example of how this traffic would flow would be something like I want to connect the cameras on my Leader demo center, which is right behind me, to the NAS that is in one of my other subnets at the Leader head office. So I'm just on my little PC at the moment, and I am connected directly to the different like the switch in my environment, and I want to check how the traffic can get to that NAS, which is remote. That's something that's sitting across the internet. So I'm on my device right now, and I can ping the camera that is like on the same switch as me. It's in a different subnet, but Ubiquiti does allow inter-VLAN routing by default, and I can reach it. But if I try to go to the remote site and try to ping that, we'll see that it fails. So 10.0.10.61 in this instance, which is at the head office. That's the NAS that I'm specifically trying to reach. It's Ubiquiti NAS. So a couple of reasons this is happening. For our testing purposes, I want to kind of replicate it as if I was a camera or as if I was the NVR, and I need to reach that environment. So what I'm going to do is I'm just going to jump into the same network as the cameras in this instance. So my NVR and cameras are on the same subnet there. It's going to take a second because obviously I'm connecting to it, so I need to do op, release, and renew. I have a nice little command to do that, and within a few seconds it should restore connectivity. Just a note as well here that sometimes your IP address will change on your device, but it might not show the correct or new IP address instantly. It sometimes takes a bit of time. So in this instance, it's still showing 192.168.1.99, but if I go check my actual settings on the device, it's already updated to the camera network. It's a timing thing. Ubiquiti just needs a bit of time to refresh that. So I'm still trying to reach that NAS. I can reach the camera, and obviously I'm in the same network, so it'll even be slightly faster. But why can't I reach the remote NAS? One of the reasons that's prevalent is because I chose to connect my camera network and the other side's camera network. So if I go do a ping test to the 30 range here, so 30.1, which is the gateway, you'll see I can actually reach from my camera network on the Lido demo center to the camera network at the Lido head office. But my NAS is in the home network. So what I do is just add this in. It takes a couple of seconds for that to update. I can add any other networks that I feel while I'm here. And I just give this a few seconds, and it's OSPF and WireGuard should just establish a tunnel that allow me to connect. You'll see it takes a couple of ping tries, and it eventually gets there. So still trying to reach that location. There we go. Tunnel's now established, a couple of pings, 10 pings, and I'm actually able to reach that NAS. So it now means that I'm in the same network as that NAS, my device is in the same network, which means I can potentially reach it. What I can do now is go over to Protect on my Ubiquiti NVR, and I can set up this NAS. That's just a quick example of how it can be done. I basically just need to point it to the IP address of that NAS. We know what it is. It's 10.0.10.61, which is on the head office, and I'm at the demo center. And what I can do now is go create a user for this NAS so that I can have a backup account. So just going through the process very quickly so you can see how easy it really is. I just need to give it a username and password. We know on a network level it's reachable between each other. And while I'm here, I can also do the drive assignment to say that this storage, this NAS backup is going to be 20 gig, whatever, you can specify to what you want. You don't need to even send out the credentials to anywhere. You just take that user account, the details that you've created, username and password, point it to the IP address. It knows what the port number is by default, and just go connect. So this again just takes a couple seconds. It says NAS now connected. And now I can pick which drive I'm going to save to if there's multiple drives assigned to this user. And it's done. I can now archive to that remote side. I can also still archive to other things as well, like Google Drive or something similar. There's also new functionality to allow continuous archiving, just as an FYI for the guys that are using Protect. We can choose which cameras to back up during which times. And you can say, for example, that if a smoke alarm is detected, the building's burning down, then push the video footage out to a NAS so it makes a backup of that video footage. That is a common example. Another thing that we can do here is if I go to my camera playback or my timeline, we'll see how easy it is in Ubiquiti's NVRs. Sorry, it's not really a promo of the NVRs, but just to show you how quickly we can actually push the footage out of this and get it to someplace else. So this is now going to go across the internet. What I'm doing is I can just click on archive event, point it to the NAS, and it's now busy pushing that 17 megs onto the other side. It's super fast to get there. Obviously, it depends on your WAN connectivity, etc. But it is a very quick way to get there. Even if I go back into that now, you'll see it takes a couple seconds for the drive to update, but it eventually has that 17 megs of video footage stored in there. So this is a really useful thing, and especially for like continuous archiving or intermittent archiving. And this is a very common scenario that we come across where people want to back up footage, and it can be from anything. It can be from a third-party NVR, it can be whatever you want, provided that they have a backup mechanism to push the footage out to something else. You 100% can do that. And as you can see there, it has now updated to 17 megs, 17.8 megs. So that footage is now safely stored. Really cool way to do it, and it's a really intuitive mechanism as well. So that site-to-site VPN is established, it's working, and potentially if there was failures along the way, it would still manage to route the traffic as best it can. So there is a bit of a trick that you can do here as well, just as an FYI for the guys that are looking into this. The Protect side doesn't support Amazon backups just yet, but the NVR side, the NAS side does. So you can potentially push the footage from your NVR to the NAS, and then from the NAS, you can either push it to another NAS or you can push it to cloud services such as Amazon S3, Backblaze, etc. So it's a cool way to move your traffic out and easy to link as well. If you're trying to create a subnet that overlaps, so let's say you've already like established the site-to-site VPNs, but now after the fact you need to go set up a new subnet on one of those sites. If you try to specify something that's already in use, it will warn you and it won't allow you to use that. Say Site Magic is already in place. You can't reuse the subnet. It's already being used by something else. So it keeps you honest in terms of not accidentally overlapping into different subnets again. There is also just a ton more capabilities around this, but it's a super easy way to get it done. One of the last things I'll do here before we look at the hub and spoke is look at like trace routing to the NAS. So what I'm doing is I just want to show you what the process flow is. So I'm on 10.0.40.99 and I'm trying to reach the NAS, and you'll see it goes to my local gateway and then to a 192.168.7 address. But if I go through my networks and all of my site-to-site VPN listings, etc., there's no mention of that subnet. So I was wondering where that's visible. The place you can see it is if you go to, after you establish the VPN, if you go back to the manage settings, you'll see it actually has a separate subnet that it's created. That's the common link between all of these sites, and that is 192.168.7. whatever. So it's looking at, it will automatically set that up for you depending on your network ranges. So it's literally just gone from my local device onto the Site Magic VPN subnet, and then it just found the other site or the address that I'm intending to reach via that subnet. So it knows that if the traffic or if the resource that I'm trying to reach, the host, is local, then route the traffic locally. That's obviously part of OSPF. OSPF will always try to find the shortest path to a location. If I do something like try to get to a public internet address like 8.8.8, it obviously knows that this isn't something that's going to find in my local address range. So it immediately goes to my local gateway, which is just the internet address, 10.0.65. If I look at my WAN settings here, I'll even see this. So 10.0.65 there. And it just means that instead of trying to go through another site and then go out to the internet, it just goes directly out to the internet. Again, part of OSPF and part of the internal routing of these devices to manage traffic in terms of reaching its destination as quickly and as directly as possible. So if I jump on over here and try to go to one of my other gateways that has the public address. So this is the leader head office. It's got an address of 122.199. If I try to trace route that, we'll see that it still goes across the internet. The reason is if it's not finding it in the local address range, it's going to go out into the internet to find this address, which is exactly what it's done here. It's a public address, so it knows instantly to go out to that. So it's again, very dynamic routing mechanism. For your perspective, people just basically, or Ubiquiti just wants it to be a transparent thing. We don't have to worry about it. You don't have to worry about how the routing set up. You can still create manual routing processes as well. So this does tie into the firewalls and the routes, dynamic routing and static routes. And I can say that specific traffic is directed to specific things. So for example, here I can say that all traffic intending to go to the region of South Africa should pass via another route through one of my other gateways. And that's exactly what's happened here. So I'm just typing in a IP address that's in a South African region, and we'll see the gateway that it comes up with. So scrolled up a little too far there. It goes to my local address first, so 10.0.40.1, and then tries to direct the traffic to 192.168.7.4, which is the remote gateway that I specified. And then from there on out, it reaches out to everything else. Basically allows the traffic to go out from there. Where we would actually use this is, let's say you have a branch in South Africa and you want the traffic to be encrypted all the way until it gets into South Africa and then break out from there. This is a very common use case where people have different branches scattered throughout the country or throughout the world, and you want the traffic to be secured until a certain point and then break out to the internet. There's a ton more scenarios that you can do here about testing failover capabilities, all the different routing, dynamic and static routing options, etc. And it's the same whether you're using a mesh network or mesh VPN or a hub and spoke. So moving on from that, we can start talking about hub and spoke setups. So where do we use this? There's a bit of theory behind this first before we start looking at the practical setup again. Just to understand the process. So in a hub and spoke setup, all the remote sites are considered spokes. So you will have one central hub and multiple downstream or connecting spokes. These spokes build their VPN tunnels to the central hub only, and they don't establish communication between each other, not by default. So spokes don't connect to each other unless they are explicitly allowed to do so. So this is ideal for environments where we have traffic that should go through one central point or to one central point for stuff like access control or specific services or for security reasons. A common example would be something like where you have a main head office. Let's say your fast food restaurant chain. You have a main head office that hosts your point of sale terminal, your software that you use, and all of your restaurants that you have scattered throughout the country should be connecting back to that main hub. That's exactly what this hub and spoke mechanism is built for. The benefit with this is that, firstly, it's much more secure. If there's an issue that happens at the Sydney office, it doesn't impact the Melbourne office. Any one of the spokes essentially would be isolated from the traffic of any of the other spokes. The other big benefit here is that it's firstly much more private and secure. The other big benefit is that it's much lower bandwidth and we don't need as many VPN tunnels. So with the mesh topology, we needed to have a VPN tunnel for every single other mesh point. So if I have 20 branches, I need to have 20 separate VPN tunnels. With this, I potentially only need to maintain one VPN to each of the branches. So one VPN tunnel, which means potentially it's lower throughput, higher bandwidth, and the big thing here is it's ideally built for environments where the downstream connecting site doesn't have a lot of throughput. So if you have LTE or Starlink as your primary connection for your restaurant, for example, then it means it's a much simpler connection back to the main hub. And the big benefit is obviously it's secured via WireGuard. So it is a fully encrypted connection back to that main site. So that is a ideal use case for this. Hub and spoke topologies typically use far fewer tunnels, and it typically means that the CPU load and bandwidth is also much lower. So there's a bunch of advantages to this. Um, one of the last ones to quickly mention here as well is that you can potentially have a central firewall and all of your downstream connecting sites, your spokes, um, can potentially use that for the main firewall before traffic ingresses to the rest of your different gateways. The biggest benefit with this by far is scalability. So with hub and spoke setups, you can do 1,000 remote sites. So one hub up to 1,000 spokes. That's pretty crazy. Like you can think of your customers, how many of them really have 1,000 branches? Typically not that many. And one of the other places we also see this a lot is for companies that enable remote work, where they give their employee a gateway and just go, we have 250 employees, all of them get a gateway, and they get home, they connect that to power only and the internet, and it automatically establishes a site-to-site VPN, and they can work as if they were connected to their local network in the office. The drawback to this topology is that one hub is the central point, and it means that if the central point is down, you're going to have a bad time. We can actually set up in Ubiquiti a backup hub as well, but you need to configure this. I'm going to show you how that's done. So the central hub could also be a bottleneck as well. If you have something that's very low powered or doesn't have a lot of throughput on the main hub, it could be a potential bottleneck. So you need to make sure that you have enough capacity and throughput on that site. If you do want to allow inter-branch traffic, so let's say, for example, all the traffic should by default go to the main hub, but I sometimes need to connect to the Melbourne branch because there's a NAS that I need to back up or something along those lines. You can do it, but you specifically need to allow it, and you also have to set up DNAT configurations to do that. So it's a very flexible way in how it's done, but we need to be cognizant of that reliance on the hub. In terms of the hardware, what this would actually look like, you can use any combination of hardware here. It doesn't specifically have to be Ubiquiti EFG or something along those lines. It has to be, can be any Ubiquiti Cloud Gateway pretty much. There is some exceptions. I think it's just the UXG Lite or UCG Lite that doesn't allow this, but most of the Ubiquiti gateways does allow this functionality. So again, just staying aware that one of the hub typically needs to be a large capacity device. So I would typically recommend going for a EFG or something along those lines for the hub, and then the rest of them can be whatever hardware you prefer. So hub and spoke, in a more technical term, would actually look a little bit more like this. So it again just uses OSPF. For those of you that don't know, so OSPF, very briefly, it's a broad protocol, but very briefly, it's a dynamic routing protocol and basically just tries to find the fastest and shortest, most specific path first. So it always tries to find the quickest way to get somewhere. So a quick example of that might be like if I'm trying to reach a NAS in our Sydney office and there's a direct path via the VPN. So from going from Melbourne to there, there's a direct path via the VPN. Then I can use that instead or use that first, as opposed to trying to go out to the internet and then eventually finding it. It will always try to use the most specific path, and the most specific paths tend to be local. Unless you tell it otherwise, you can still obviously do static routing and stuff like that. So with all of these VPN technology, you can still apply firewall rules, static routes, different NAT rules, and obviously change where that traffic gets directed to. So we've done a quick refinement in the topology here. So it's not in the real world just a simple connection back to a main hub. Instead, it would look something similar to this, not 100% to scale, as they would say, but something along these lines. So we have to consider both physical and logical interfaces. This again it's very theory heavy, but when we see this in practice, we'll see what I mean. So the physical interfaces would be the physical WAN ports or LAN ports on the gateways. So each of these would be little UCG Max or whatever it is. Obviously, these have limited number of LAN and WAN ports. So that's one of the considerations when we're designing this. In our example here, just each one of these devices has a single WAN port. That's fine. It works in this topology. You can also have a hub that only has one WAN port. So that is the physical interface. We also have logical interfaces or logical VPN tunnels. And it's important to understand that even if you have one physical connection, like a WAN going out to the internet and connecting via tunnel to your main hub, that can still be multiple logical interfaces on a single connection as well. So we can potentially have 4 VPN tunnels going back between the Sydney office and the main hub, even though they both only have one physical WAN. You don't get, for example, a Ubiquiti gateway that has 4,000 WAN ports on it. So it would be impossible to do a hub with 1,000 spokes if you had to follow that. But you can do multiple logical VPN paths, even if you have only single or a few physical WAN ports. So in this example here, we basically have a hub with a couple of spokes. Each one of these have a physical and logical paths, just one of them each. What this gives you is that if all the spokes and connecting points basically connect back to this hub, it's reliant on this hub for primary connectivity. Okay, so one thing to keep in mind with this is like a lot of the other implementations of site-to-site VPNs with hub and spoke mechanisms typically means that all the traffic then goes through that hub and all of it goes out to the internet from there. And if that hub is down, then everything is broken. That's not necessarily the case with Ubiquiti. Because our devices are still gateways, so they are still a physical gateway device that's capable of reaching or connecting to the internet on its own. If the hub is unavailable, it still can do connectivity to the internet. You can still maintain WAN and you can still connect to whatever you want to. The main thing is just if the hub is down, then it essentially means that I can't reach the resources on that hub. And potentially I can't, if I had inter VLAN connectivity or into VPN connectivity, it potentially means I wouldn't reach any of the other branches. That's why, or that's what it's responsible for. So when you're in this topology where you just have one physical WAN on both the spokes and the hub, just be aware that where there is a failover, so if this hub had to fail over to secondary WAN, for example, or any of the spokes had to, there will be a service disruption because it's just one connection. It's typically a couple of seconds while that failover process is in progress, but it's still an interruption. For mission critical environments, this isn't what you want. An example might be like a patient management system at a hospital where you need to be able to reach it very quickly. People's lives depend on it. You can't have any downtime. That's exactly what we can expand out to. So again, the implication is if a hub fails, potentially all the spokes would fail to have connectivity to that hub. When it switches over from an ISP to another ISP, if it has a secondary WAN, then it should also maintain the best path possible based on its WAN information. It has dynamic routing capability, so it can fail over potentially to other hubs as well, or other WANs. So you can specify in the interface how many WANs the hub has. The individual spokes will also have the ability to use multiple WANs, and you can specify what happens in case of failure. In Ubiquiti, it's actually called failover mode. We're going to show it to you in a moment, where we have a single VPN tunnel, but if there's a backup WAN on the hub, then we can fail over to that instead. So again, if the hub fails, it doesn't mean the spoke stops working entirely. It just means it can't reach the resources that it's trying to get via VPN. Another example is, and we're kind of oversimplifying this a bit, is where we have one port on the hub or one WAN port, and multiple logical paths to the spokes. So this would be, let's say, for example, 4 VPN tunnels going to each one of these spokes. And yes, that is supported as well. So the big benefit with that is if you have multiple VPN tunnels, you can have routing resiliency. So if one route fails, it can follow through another VPN or another tunnel. So again, even if it's just one WAN, you can have multiple paths. So if one logical path or route fails, it's seamless handover to the next one as well. So even if it's just one WAN, it can dynamically choose between them the different paths, which is best. It'll also use dynamic routing for that to decide which one of those paths is fastest, shortest, and potentially the highest throughput as well. In this topology, you wouldn't have downtime if one of the logical paths fails, but if a physical WAN port or the internet fails, then obviously you're still going to have downtime, but that's a broader scope of problem. So some of the deployments we've seen is where people have a VPN for all of their traffic back to a main office, typically with some resiliency for multiple VPN paths. But then what they'll do is they'll also fire up a secondary server that is potentially on the public internet, where that's designed to handle less secure information. So what they can do is they can say that everything should go across our VPN by default, but if the hub fails for some reason, then just go to a internet address that we have hosted, and the site can potentially connect to that to still maintain connectivity, although it's less secure. In most real-world deployments, though, you're not going to have just one WAN on a hub and one WAN on a spoke. If you think about your Ubiquiti gateways, most of them have multi-WAN support. Most of them now support up to 8 WANs. So you can potentially say any one of the LAN ports on that, UDM Pro Max, for example, can be a WAN port. So in the real world, we'll typically have multiple WANs. Again, up to 8 is the maximum on Ubiquiti. So one of the other supported mechanisms, and this is again an option we can select, is where we have 2 VPN tunnels, and Ubiquiti call this simultaneous mode, or sorry, a redundant mode, and it supports up to 2 simultaneous VPN connections or 2 simultaneous VPN tunnels to each spoke for both the primary and secondary WAN to the hub. So in our example here, I'll take Sydney again and go, okay, cool, I have 2 WAN ports here, 2 WAN ports on the hub, and I can potentially point, like I can say that one of the VPN tunnels goes through to that WAN port, and the secondary WAN connection goes back through to that WAN port. Okay, so there is going to be some contention around this mechanism. This is the way that it's written and tested on the Ubiquiti side. In the real world, there is possibilities to still do stuff like say that if there's failover between any of the WANs, then move the traffic over, or the VPN tunnels over to another point, etc. So there is still like a million different ways this can be done. I'm primarily focusing on the way that Ubiquiti has it implemented as the default settings. So just to be clear on that as well. So when you're looking at the scenario and you have 2 WAN connections here, 2 WAN connections there, 2 VPN tunnels respectively, if one of the WANs or VPN tunnels fails, it doesn't actually cause downtime because it will just seamlessly connect through to the secondary VPN tunnel. Again, it will know the path cost, it will try to dynamically route through the one that is fastest as much as it can, but if it needs to fail over, it is also possible. It is also typically recommended to use multiple ISPs. So if there's a problem on one ISP, then you can fail over to the other. Multiple WANs, multiple ISPs. We can massively expand on this in terms of both physical connectivity as well as logical connectivity as well. So we can have, for example, multiple WANs from the spokes. So each one of these spokes now has 3 WANs. We can have multiple WANs on the hub. So potentially, let's say, up to 8 ISPs and individual WANs connected on the hub, and all of that for resiliency. Again, we can also even take this a step further and direct specific traffic to specific WAN ports when it's linking through to the hub. There is that granular control as well. So multiple paths for the hub to come into, or for traffic to come into the hub on the WAN, and more paths for the traffic to go out from again from the hub to the spokes as well. You can have more path diversity. And in Ubiquiti, this is called highly redundant mode, which basically allows you up to 4 VPN tunnels per spoke, and each one of these spokes can have multiple WANs, of course. So be aware that more tunnels equals more processing and throughput requirements. So just something to stay aware of. If you have multiple VPN tunnels, um, again, which path would be favored in terms of routing is determined by OSPF. So it'll decide the shortest, fastest path to get there, most specific path. Okay, and then we can expand on this even more. So each physical WAN can still have multiple logical tunnels. So multiple WANs, multiple logical tunnels. Um, it's very, very scalable from that front. And then you can even have hub level redundancy as well. So what happens if a hub fails? You can potentially fail over to a secondary hub. So in the interface, we're going to set this up in a moment. It's very short. It's a quick way to do it. So in this example, we have a spoke with 8 potentially physical WANs. That's connecting up to a couple of ISPs or a couple of WANs on the main hub. If the hub dies for any reason, it can fail over to a secondary hub and again apply all the dynamic routes and all the OSPF and VPN functionality that needs to from there. And if any of the WAN like services here fail, I've removed the other spokes here just to make it easier to see. If any of the connections fail to any of the ISPs, it can again dynamically select the different WANs that it needs to fail over to. So a good example might be where you have enterprise Ethernet as ISP1, NBN as ISP2, 5G as ISP3, 4G or Starlink as ISP4. And you can say this is the priority that I want to fail over into. So multiple VPN tunnels going through ISP1, and then when that fails, then we'll go to WAN 2, etc., to keep it up. So we can have 2 hubs with 8 WANs each. Again, that gives you an idea of scale. You can fail over between these 2 if a primary spoke goes down or needs to move, then it can connect over to that. And again, you can have multiple tunnels from hubs to spokes. So there's also a custom mode that allows you to specify which hub is a failover for which spoke. So I can say that spoke A here, or Sydney, primarily uses this hub as its main and that one as its secondary, but then use the other one as failover or vice versa. So again, scale and resiliency. So it does always, again, look at your closest path, at your least cost path. The one thing to also just note here is that this can also interconnect to different hubs as well. So potentially there is an interconnect mode on the hub selector. I haven't tested that myself yet, but potentially you can also take this to other hubs as well. That brings us neatly onto a good point here. I get a lot of questions around, is this compatible with third-party like site-to-site VPN technologies? The underlying tech, as in WireGuard and OSPF, is, but Site Magic itself is proprietary to Ubiquiti. So you wouldn't have brand X as one of the hubs and Ubiquiti as one of the other. So it has to be Site Magic combined in terms of connectivity. So I just want to quickly emphasize the scale here because I don't think a lot of people understand this. Potentially you can have multiple hubs, each one of these with multiple WANs, each one of these hubs again with multiple VPN tunnels to each spoke, up to 1,000 spokes, and each spoke potentially having multiple WANs. And you can even do potentially overlapping subnets with hub and spoke mechanism. I'll show you what that looks like in a sec. So massive scalability, 1,000 spokes, all of them highly resilient through multiple ISPs, multiple WANs, multiple VPN tunnels. So really, it should be scalable enough for most of your customers. Let's see what this looks like practically. Sounds like it's going to take us hours to do, but it's actually very easy. I think we're going to run about 5 minutes over time. Sorry about that. So just quickly, in the interface again, going to hub and spoke, you'll see it follows much the same logic as we've seen before. Essentially, I'm just specifying my hub topology. Is this a single hub? Do I have a failover hub that I'm intending to use as well? If you have multiple sites with multiple static external IPs, then yeah, that's fine. Or I can go the custom path, which I'll show in my next slide as well. And then we can select the number of VPN tunnels. So is it just failover? In other words, a single VPN tunnel where it will fail over to a secondary WAN if that device has it? Or do we have a redundant path? So basically, this is where it maps the WANs on both the spoke and the hub to each other. And then we also have the ability to increase the path counts as well to up to four VPN tunnels. Of course, the hub needs to have a public IP address. The spokes don't necessarily need to have public IPs. They can just be regular CG-NATed devices. In this instance, I've selected all of my downstream spokes, and you'll see now I have in my hub the option to configure a bunch of stuff. I can choose what networks are or what routes are part of this route advertisement on the hub. So I can say that if I have a static route or something along those lines, or a subnet that I want to advertise, I can add that in. I can just add a note to it. Same thing for networks. It just allows me to select the networks which are already on the hub if I want any of them exposed to it. I can say for our example here that the camera network, which has my NVR on it, and I want to push footage from my downstream spokes to it, I want to expose that. I want to make that available. The primary WAN or primary VPN WAN basically just allows us to choose which one is the primary WAN, and I also have a WAN failover mechanism as well that I can tick. I only have one static external IP on this and only one WAN, so unfortunately I can't select WAN failover mode. And then to the right of that, it shows us the number of VPN tunnels that's going to establish to connect downstream to all of these different spokes. Okay, and then when we get to spoke networks and a WAN setup, you'll see it has an option that says enable subnet overlap. That basically allows us to reuse subnets across multiple sites. What I'm going to do first is just replicate what we had in the mesh network, and I'm going to basically just select the different subnets in each one of the spokes. If I again select a subnet in one of the spokes that overlaps with a subnet in any of the other spokes, it's not going to allow me to select it. You'll see there 192.168.1.0 is blanked out, and that is because I've already picked it on another gateway. And what I can do now is just select all the different subnets that need to be combined to each other that allows access. The Sydney one here, like it directly clashes with one of the other branches, so I can't actually pick that one. And I can also, if that is the case, deselect that from my mesh that I want to create. Sorry, not my mesh, my hub and spoke, my VPN. Once that's all done, picked, it's super easy to do. You just go create, and that is your site-to-site VPN established. It takes a few seconds again to fire this up. Hub and spoke does take a little bit longer, but it is also super fast to do it. We've also asked for Ubiquiti to implement ways to do speed tests across the multiple VPNs. They've already added a latency into that, so we can see how the latency is between sites, but it would be nice if we can do speed tests between them as well. So I believe it's already on the roadmap if I remember correctly, but it should be there. Also for the guys that are sticking around, sorry, I know we run slightly over time. If you do need to bail out early and you want to catch up on the rest of this afterwards, you will receive the recording directly after, so you're welcome to grab that if needs be. We're almost done, so just quick last couple of ones to show here. One of the other cool things that you can do through this as well is if you have your site-to-site VPN established, of course you can check the latency like I just said, but you can also do, you can drill down into each one of the sites to go make configuration changes, etc. Obviously, we're all familiar with this super simple way to do it. The cool one that I want to show is actually the topology. So let me go over to maps, and I can see where my different sites are in terms of geographical location. It's based on the location that I set in the GUI of the gateway, but this allows me to see where my sites are. So very easy to visualize my different connections and understand what networks are connected and how we basically have our site-to-site VPN set up. This is one of the things that, again, it's a pain point in traditional IT because you struggle to remember where everything's at. Okay, last one here, and then we're pretty much done for today. So the rest of the settings in the hub and spoke mode are very simple. We've kind of covered all the different topologies already. So failover for just basic redundancy, 2 VPN tunnels for high levels of redundancy, and ultimately for maximum. For our hub, like if I want to set up a failover hub, I need to have a hub that has a static external IP in order to select it. Again, I can't do this in this one. And of course, I can add on additional sites after the fact if I want to. The cool one that I want to show is as soon as we start going into custom mode, we'll see that I get a few more options added in. So flick over to custom, and you'll see that we can now do stuff like, again, select multiple hubs. In this instance, we can say which hubs are also connecting to which spokes. So we do that through the spoke to hub routing mechanism. So it can either be just via geolocation, proximity, or it can via custom, which allows me to specify which hubs connect to which spokes. So you can add these routing mechanisms in or routing paths in, and it will know how to get there. And then there's the option that I was talking about where it says interconnect hubs. So if you have other hubs that you want to connect beyond what you've set up in this site-to-site VPN, you can potentially use that as well. And then, of course, in terms of the routes, etc., everything's still there. So a quick note on how the SNAT functionality works. So if I enable subnet overlap, it basically creates one large subnet that all of my spokes connect to. So instead of looking at the individual subnet on the gateway, I specify one massive subnet. You'll see it's huge because it's got a -12 notation. So the CIDR is massive, so it gives us a 4092 unique potential IP addresses or subnets, sorry. And what we can do is each one of our branches in this instance gets a unique subnet that is not part of their existing subnets. It allows connectivity between like the Adelaide and Brisbane branch, for example, without like the subnets that clash on both of those branches to interfere with each other. So it's using OSPF again to establish border gateways, and it's just going, when you get there, then use a different address range. It basically just allows you to reuse subnets across multiple sites. So if you have customers where you've already gone down the path of setting up 192.168.1.1 as the default for everything, then you would want to enable subnet overlap mode. And the last one there is isolate spokes. All that function does is it just builds a firewall rule for you to isolate the spokes. So by default, the traffic shouldn't transverse across different spokes anyway, because that's not the logical routing path. But if you actually want to restrict it out and block it, you can via the gateway firewall capabilities as well. And that is pretty much it for hub and spoke. So again, we are limited in terms of what we can show here because like I don't have multiple static external IPs and thousands of sites, etc. But in practice, this is something we can like very easily set up. It takes a few minutes to go through. It's super simple to do.